Force vectors. What are they? How do we use them? Questions we all have in life. Okay, a force vector is right up here, is a vector quantity. Vectors, by definition, have both magnitude and direction. It's like if the opposite of that is a scalar. Scalar quantities have only magnitude. I may be going 55 miles an hour. Vector quantities have magnitude and direction. I'm going 55 miles an hour to the right or due north, but it has a direction to go with it. So vector quantities, which is what we're going to be talking about, they have both magnitude, the size of the force, and direction, what direction it's going in. So they give an example. A lot of times we draw it as a line with an arrow on the end. And so the magnitude can be the length of the line segments, in this case 3 units, and the direction 30 degrees counterclockwise from the positive x-axis. This is really the best way to label it, in a counterclockwise direction from the x-axis. You can do it a lot of different ways, but we also have what's called a sense, which I would say that this would be going up and to the right, okay? Up and to the right. So that's a sense of that vector. Now, I'm just jumping through this, going through this fast to show you how to find them. Because when we have this force vector, like this one here, 75-pound force vector at 35 degrees counterclockwise from the x-axis, I need to break that apart into its x and y components, okay? And it's like with the free body diagrams, you know, when you're pulling on something at an angle, if I'm pulling on a wagon with a rope, if I want to, whether I can pull that wagon forward depends on whether my x component is greater than the weight of that cart. And so while I may have my overall force on the rope may be big, if it's not big, if this is not big enough, it's not going to move. Okay, and so we use the right triangle. So we use trigonometry. We use our sines, our cosines, and find our numbers. And this is broken down into the most simple of formulas. I've taken the normal SOHCAHTOA, sine equals opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent opposite over adjacent. We've broken down that if it's an x component force, use f sine of theta, theta being my angle, and if it's an x component force, use f cosine of theta, theta being my angle. Now this only works if you're measuring counterclockwise from the x-axis, as I'll show you in a minute. But for this particular one, okay, is if I use this. So for this one, for example, if I want to find my Fy, it's going to be my F, which is my 75 pounds, sine of my theta, which is 35 degrees. And my Fx is going to be the same thing, 75 pounds, but now it's the cosine of 35 degrees. And when I plug those into my calculator, and this is where you really have to understand your calculator in order to be able to do it. So 75 times, and I believe this calculator, let me say 35 sine equals, and yeah, that looks right. So I get 43 pounds. And if I do 75 times 35 cosine, I get 61.4. And so this is 43, and this is 61.4. And if we did the Pythagorean theorem, a squared plus b squared equals c squared, that should work out. Okay? And you can see that, oh, I did these wrong. Oops. Never mind. This is 43 because this is my y, and this is 61.4 because this is my x. And you see how I did that? Oh, because I noticed this should be greater than this for this triangle. If my angle is less than 45, my x should be bigger than my y. And this is, by inspection, you start learning when you've made a mistake, like I just did. I did that on purpose, I like to think, even though that's not true, but it is important. That's how you do it. If I look at it and go, this should be bigger than this, and yes, I had f sub x, f sub y, okay? So, a couple of quick more examples here for the angles. So for this one, yep, still got it. F sub y equals 180 sine of 60. F sub x equals 180 cosine of 60. This one is going to be f sub y equals 480. Now, slow down here. Here's the thing. You could put in 30, but you got to remember this is going to be going downward. This is going to be negative. This is going to be a negative y. Just like over here, this is going this way. So it is a negative x, depending on the quadrant it's in. Positive xy, negative x positive y, negative x negative y, positive x negative y. You have these four quadrants in the graphing. Okay? So you could put in 30, and if you do, you just have to remember to add a negative sign at the end. But I always tell everybody, you could also do it counterclockwise from the x-axis, and I could say 330 degrees. If I do that, it will automatically put in the negative sign for the y, but not for the x. So f sub x equals 480 cosine 330 degrees. Okay? And then this last one down here. So this one is going to now, and this is also another interesting one, f sub y equals 640 sine. Now again, what people want to do is use this 70 and say that's 70 degrees. No, always measure from the, if you always measure from the x-axis. So I want to measure this angle here. Okay? You could also have measured this angle here and done it that way, but then you might not get it. Then you have to remember the negative signs, because basically what I'm doing is I'm finding this x and this y. Those are my x and y components. Right here, I'm finding this and that. In this one, I'm finding this. Basically, I'm constructing a right triangle in each case, but it would be these, not these. Okay? And so I'm going to do, I would add 70 to 90 and get go back to black, 160. And f sub x equals 640 cosine 160 degrees. Okay? So what you would want to do is get your calculator out, run these numbers first. I'll wait a few seconds, and then I will put in the answers. Is this what you got? So here's the answers, here's the calculations. So again, if you look at it over here, this becomes, so you have my x's, this is my 415, and then downward is my 240. And these are not drawn to scale. I mean, that's 60 degrees, which is actually be more like up here, which is why my y, again, if it's greater than 45, my y should be greater than my x. Okay, and over here, because that's 70, so this is less than 45, so my x should be bigger than my x should be bigger than my y. So it's that simple. For the basics, for the minimum you have to know in order to be able to solve the truss problems is you have to be able to do these type of force vector finding the component. This is what's called finding the components of a force vector, finding the x and y components right here. This is what we just did. We found the x and y components of the force vectors, okay? Thank you.